All right, so this is 7D practice. So for 1 and 2, we just have to identify the number of zeros. So this is really looking, is it in standard form? Is the function in standard form? For number 1, it is. There's different terms. The terms are joined with addition and subtraction. And the polynomial is written from biggest exponent to smallest. All you really need to look for identifying the number of zeros is the biggest exponent. So there are 4 solutions here, or 4 zeros. Since it says zeros in the direction, maybe we should have zeros, but 4 solutions, or 4 zeros. On number 2, there are different terms, so that's part of being in standard form, but you should also have it written from biggest exponent to smallest. It does not. We don't actually need it for this. You're looking for the biggest exponent, so it's, again, 4 solutions or 4 zeros. On number 3, identify the zeros. So now we have to actually identify them, not just tell how many they are, but actually tell what they are and their multiplicity. So for this, we're going to actually break it down a little bit more here. So the first step is to solve, or we want a 0, so we need the y value has to be 0. So I'm going to set the y value to 0. Then our next step is to take each factor that has a variable, because we have to have a variable to solve for it. We have a factors. Technically 3 could be a factor, but 3 doesn't have a variable, so I'm just going to lump it together with 3x squared. I'm going to take each of these factors and I'm going to set them equal to 0. I didn't need parentheses in the last one. Now we're going to solve each individual equation. So you have to do reverse order of operations. So if you have addition or subtraction, do that first, then multiplication, division, and then cube root. So x equals 0. And our next one, we have square root. Well, square root of 0 is 0. You're going to find that these exponents are really kind of useless right now. Add 1, add 1, 1. And the last one is just adding 8. Don't need the parentheses for anything. Now, we also, these are the solutions. These are the zeros. Identify the zeros, and now their multiplicity. Multiplicity comes pretty easy. This is where you just look at the exponents. So this first exponent is 3. So this is at x equals 0, it has multiplicity of 3. On the next one, we have a 2 as an exponent. So this has multiplicity of 2. Most of the time we just write it MULT, short for multiplicity or multiple. And the last one, there is no exponent there, but you really could put a 1 there if you really want. And so that is a multiplicity or a multiple of 1. Now, I don't expect you to write this, but you certainly could just for commonality, making sure that you're still keeping with the same. So if you write multiple of 1, it's not part of the answer, but you can if you'd like. On the next, so number 4, we have set f of x equal to 0. Really doesn't matter to me if you do this step, but in order to solve an equation, you really should have the equation equal to 0 so we can solve for the each factor. Then we're looking at factors. We have factors, multiplication. Split it up so it's negative x equals 0, 5x plus 3, and you don't need the exponent, but it doesn't hurt to have it, and x minus 2 to the 8th power equals 0. Solve each one. Well, this negative x looks kind of weird, but most people put a negative 1 there. So you divide by negative 1, 0 divided by negative 1, still 0. We have cube root is the opposite of to the 3rd power. And the exponents don't really have an effect on the actual number of the solution, just the effect on the multiplicity. So negative 3/5 is the solution. And the last one, we never did anything with eighth root or 8 to 8th power, but it'd be like an 8th root, which would cancel or simplify with the exponent. Now the exponent is gone, so we can drop the parentheses, and the 8th root of 0 is still 0. But what that does is it tells us there's a multiplicity there. So now I'm going to go back and look at the multiplicity. The x in the first, so for this I'm looking at exponents. The x is raised to really nothing. You could put a 1 there if you want, so there'd be multiplicity of 1, but I'm not going to write that. The 5x plus 3 is raised to the third. That has multiplicity of 3. So negative 3/5, there's a multiplicity of 3. And then x minus 2 is raised to the 8th power, so that has a multiplicity of 8. All right. Next, we're looking at determine the number of real and imaginary solutions. So given that this is degree 7, that means that there are 7 total solutions. You then need to determine the real solutions. Well, the real solutions is right along the x-axis, the x-intercepts. Anytime a minimum or a maximum point, a local min or a local max hit the x-axis, that is a double solution. So this is a multiple of 2. There are 2 solutions there. We counted twice. This is the next one at 2. Goes through a pretty straight line, so that's linear, so that has a 1 solution, or a multiple of 1. So there are 2 solutions at 0 and 1 at 2, so that's total 3 real solutions. And there are 7 total, 3 real, so then the other 4 have to be imaginary. On number 6, degree 5, so we have 5 total solutions. We have 1, 2, 3, all are linear. They go through the x-axis on a pretty linear line. So those are all 1 single solution, so there are 3 real. If there are 5 total, then there has to be 2 imaginary. Remember, imaginary always have to be in pairs. If there are imaginary solutions, it's 2, 4, 6, 8, 10. There's never an odd number. All right, number 7. We got to go to Desmos, graph it on Desmos. So when you initially graph it on Desmos, it just looks like it's only 1 solution. But be careful. Zoom it out. And we have 2. There are 2 real solutions. They both go through in a pretty straight line. So 2 real solutions. So 2 real. There are 4 total solutions. That's the biggest exponent. This polynomial is in standard form. 4 total, 2 real. That means there has to be 2 imaginary. And the imaginary, it's an even number, so that's good. Number 8, there are 5. Look at making sure. Yep, it's in standard form, meaning there's nothing to simplify, and its biggest exponent. You look for the biggest exponent. So there are 5 total solutions. And let's look at that on the graph. I can't see anything. Let's go back. Zoom it out just to make sure. I'd zoom it out to like negative 40 or something. Looks like it's just those 3. I'm zooming them in. Looks like they all go through in a pretty straight line. So there are 3 real. 5 total, so there's 3 real. There has to be 2 imaginary. Again, it's an even number, so that's good. All right, hopefully this helps you with the 7D practice.